Thanks to PCBWay for sponsoring this video with a brand new pulley, which is actually to replace the one that got hit by Iron Tooth repeatedly in one of the last set of fights with the Melty Brain. And honestly, this thing is actually still serviceable. It would still absolutely work. It held up amazingly well to that damage, but I'm going to retire it or use it as a spare and have a brand new one ready to rock and roll. But yeah, I love these parts. These parts come out so well, and they really do actually stand up to combat surprisingly well. I was fully expecting Iron Tooth to shatter one of these, and he just didn't. He tried his hardest, but the pulleys came out fairly well intact. Hello everybody, I am Ben from Team Panic. So today we're going to try and fix the Melty and try and get this thing melting properly. We have tried a number of different things in the past, and while we have got some level of melting going, we've never got a good, decent level going, and we've also got some issues with the weapon system too, or weapons system, double weapon system. So let's take a quick chat about what is actually going on with the Melty system, because the problem is fairly simple and straightforward. The Melty spins at a very, very, very high speed. It should be 1500 RPM, but looking at the actual footage that I've captured from our last couple of videos, it's more like 750 to 800 RPM. And the reason it is so slow is actually down to how we're talking to the motors. So the motors are turning on and off, or I'm trying to turn the motors on and off at a very, very high rate of speed. The problem is that the brain is not talking to the motors at a very high rate of speed. It's talking at servo pulses, which are 2 millisecond pulses inside a 20 millisecond frame. So they do a little 2 millisecond pulse, or between 1 and 2 millisecond pulse, and they wait for 20 milliseconds. In that time, the robot is spinning so fast that at full speed, we would do 216 degrees. So that's 90, that's about 100. So basically double that, 180. So about there. So we go from here all the way around to there in the time it takes for one signal to go through the system, which means that we can change the direction of the motors effectively once per spin, which is not enough. Realistically, for a Melty Brain to work, you need at least 8 times per spin, because you want to be able to turn the motors on and off and on again, all inside one rotation. And by having 8, it means you've got smaller segments that you can turn the motors on and then off for inside one rotation. And so that's not good. But that is also why we're spinning at such a slow speed. We're spinning at effectively half the rate that we should be able to spin. And that's because at that speed, it does balance things out a little bit, and instead we actually get 100 degrees. So we can turn the motors on and off 3 times inside one rotation, which helps but does not help that much, because it means we don't have the fine control that we need to be able to Melty in a proper direction. And also, we're losing speed with our whole system. So what can we do about this? Well, the speed controllers that are in this Melty Brain have a different system on them. They have a D-shot system. So we're going to attempt today to talk to the ESCs through D-shot instead. But that does mean scrapping everything and going back to base principles. We're going to have to get a motor spinning from the brain for the first time again using D-shot. And then once we've got that, we can add in radio control, and we can add in checking the ESC telemetry, and we can kind of build this thing back up slowly from base principles, essentially. First things first, though, I haven't actually pulled the Melty Brain apart since the last event, so we should probably do that together and just see if there's anything really going on in here. Wow, yeah, so this is just a mess in here. We really do need to sit down and clean this wiring up. Probably shrink down some of this wiring just to make sure everything kind of sits a little bit nicer. We also need to rejig the brain board just a little bit to kind of get everything where it needs to be, I think, but it's not too bad. One of these ESCs did die, one of the drive ESCs down the bottom here, but that is an easy fix. I have plenty of spares of those because Annie was running exactly the same ESCs as these, so that is not a huge problem to deal with. The other problem that I did allude to at the start was one of the weapon system. So in here we have pulleys, and this one is okay at the moment. It is a brushless motor with a pulley mounted directly to it, but this one is not okay, and you can see that the pulley has snapped off. That's because these pulleys are effectively the same diameter, or the inner tooth diameter is effectively the same diameter as the outer edge of the motor, which is just too close, and there's not enough material there, so even a little bit of wear is snapping and breaking those. So what I'm thinking is, rather than running a tooth pulley in here at all, I'm just going to run guides at the top and the bottom to stop the pulley from, or stop the belt from wandering up and down, and we're going to run the belt directly on the motor can, but not these ones. We need bigger motor cans than these because our belt is indeed bigger than these. And with that together, that should actually make a lot of difference to this melty brain, and I'm very, very keen for that. The other thing too is we had little standoffs down the bottom here that got worn out. That's fine, we're just going to reprint those and redo those. I'll probably change them from being hex nuts to insert nuts, because insert nuts are just going to be a little bit stronger in here than those are, but other than that, I think we're going to be good to go. Okay, so I really don't want to talk about how long it took to get this next bit actually working, because oh my god, it took a while. It turns out D-Shot is a pain, basically, but thankfully we have a bit of D-Shot working now. And everything works, and these motors are going to spin up to just over 50% speed, and then they are going to stop. It is a little bit scary because it sounds wild as they get up to full speed, and I'm keeping my fingers well away from all of this because even at this speed they would be kind of dangerous, but that is working D-Shot. The thing that I was struggling with is that D-Shot is interesting in terms of its boot up sequence. This whole stuff at the start where you get the actual startup sounds and all that kind of fun stuff, I was having all sorts of trouble with that. Also, it turns out these are the ESCs out of Annie. The ESCs out of the Melty, one of them was dead anyway and had to be replaced, but the other one does not like D-Shot at all. If I plug it into this wiring with this current code that does D-Shot properly, it just does not boot properly at all. So these boot and they work correctly and they get D-Shot running, so we're going to move ahead with this. But obviously right now this is not interesting code, because literally all it's doing is getting D-Shot to boot properly and then just speeding the motors up to a 50% point and then jumping them back to a 0 or a close to 0 and speeding them back up again. So it's not useful code, and the next thing that we need to do is actually get the control working again. So we need to get the radio receiver actually talking to the chip again and have all of that running with D-Shot. This is the critical step. This is where everything could all fall over in next to no time, because at this point D-Shot is a very, very fast system that uses a timer interrupt, and the radio receiver is also a very fast system that needs to clog up some of the time that the chip can do things, which means that the D-Shot may fall over because of trying to talk to the radio chip. And if that happens, then we basically need to scratch this entire receiver and find a different receiver that uses a different protocol that we can do while also de-shotting. So this is a case of, if this doesn't work, we are back to the drawing board. Okay, we have things happening. It is even more time later because software is always going to do software things and be painful and annoying. But if we pull the brain board out the front here and power everything up, we're going to do controller first. Not because we need to, but just because I personally want to. Okay, robot is now powered up and we have drive by controller stick, which actually works pretty well. The only thing is I am not fully comfortable with it, unfortunately. Whatever is going on with the startup D-shot commands has made some weirdness happen. So when I first got everything up and running, forwards was forwards, that was totally fine. Unfortunately, the first little bit of backwards was also forwards, and then if I kept going, I hit a point where the motor suddenly reversed and went full speed reverse, like all the way down at like the very, very fast speed of reverse, and going furthest down into the end point of the stick down here, that's when the motors would go slow in reverse. So for whatever reason, the signals for the reversing are backwards from what I think that they should be, and that makes me very nervous. This is a very powerful and very dangerous machine when it's up and running, and I don't want to not understand something in this robot. If I don't understand something in this robot, that makes it exceptionally dangerous for me to be running at an event. So I don't think I'm going to be able to get this thing back up and running as a melty today because I need to get that issue sorted out in my own head and try and work out what is going on there, basically, and see if I can sort that out for myself, and if I can, then I'll be able to get this melting. However, this video is already very, very late because of all of the issues I had getting D-shot up and running, so just the fact that I can now drive in D-shot mode is so exciting. That is incredible that I can do this. And I can't do it too far because these motors are so powerful they will rip the silicon off these wheels if there's not resistance to them. But yes, I'm so excited. This is the first step towards doing a proper, actual proper melty brain, because high-speed communication between the brain and those ESCs was 100% necessary. So we're definitely going to have to do another video on this. I also think I'll probably completely redo my PCB for the next time, because this PCB is so wrong in so many ways. The actual light is taking up potential D-shot ports. The D-shot ports, or the motor ports, I've had to move from where they were to D-shot ports. The telemetry reading has a external resistor in that I don't have in here. The 5-volt regulator on the board doesn't work. All of that stuff needs to be fixed. So I think we will be doing a brand new melty brain PCB at some point in the future, which will probably coincide with getting the melty re-meltying, which will be awesome. Yeah. But the one thing I do want to do before we round out this video is go back and have a look at the weapon system again. I mentioned right at the start of this that I want to change up these motors and these pulleys, because I think that by moving over to different motors, we can just run belts directly off the motor into the weapon stack up, and that is going to save a lot of time, effort, and heartache if we can get it to work. Okay, so a couple of slight issues with this this idea. So first of all, Yeah, this belt is just a little bit loose. I'm probably going to need a slightly smaller one to get away with this idea, but I think it's going to work. Looking at this, it will actually like contact the motor. In fact, if I put a little bit of pressure on it, it's totally fine. So I almost could even just like drill a hole and put a belt tensioner in there, and that probably would do the job, I think. The other problem though is that we are hitting screws at the back that we shouldn't be hitting, because this is the same size weapon that I've had in this design before. I think it's because we have to be a little bit higher because of where this sits. So that's just a pain. I don't know what I'm gonna do about that yet. Because if we sit lower, then we don't have that issue again. And we won't have the issue on the other side because those bolts don't exist, because those bolts are literally just there to hold the power linking in place, which is very important. But we definitely need to change up where the pulley design sits. So while looking at the motor choices, I realized something, that I've been using these 2204s in the melty for the weapon system so far, but maybe an 1806, the same thing that basically everybody uses as an ant weapon motor, is going to work here, because this has already got like a 3-to-1 gear reduction, and these motors I know can throw around a 50 gram plus weapon, and the weapons on the melty aren't that heavy. They're like 150 grams at the most. So a 3-to-1 gear ratio off of this basically means that this thing is throwing around, or it feels like it's throwing around a 50 gram weight, which I know it can do. So as we are basically going to have to redo everything on this melty anyway, I've gone ahead and made up a pulley for an 1806 and mounted the 1806 in, and everything is currently actually sitting down and working pretty well. What I do want to do right now is do a spin-up test on this to make sure that the 1806 is a viable choice and does actually have the power to get the weapon up and running at a decent clip. Ha! Well, I guess that answers the question of, does the 1806 have enough power to spin this weapon up? Decidedly yes. So much so that it managed to basically destroy its own pulley. This also, well, I'm getting more bits of pulley out of here all the time. Let's take a look at how bad this is. Oh, it is very, very bad. Okay, in here you can just about work out that there is a very, very busted part of a pulley. Won't quite come out, although I think I might actually be able to go that way with it. Yeah, there we go. That's a very, very busted part of a pulley. I mean, this was just a temporary prototype piece made out of transparent PLA, which does shatter when hit, as you can definitely tell. The motor though, totally intact and fine. So that is a good sign on the whole. I mean, terrifying, but a good sign. This is also a good thing. I kind of feel justified about not getting this actually melting, because that was a software glitch. Something happened where I turned it out of the failsafe mode into the tank drive mode, put the stick up, and as soon as I put the stick up, it just took off. And it accelerated wildly, like way, way higher than it should have done. It really should have only gone to like 10%, and that would have been full, I think, before it destroyed itself. Which means there is definitely some gremlins happening in this code, and I'm very, very thankful that I did not try to go to full melty mode, because yikes, that could have been disastrous, basically. However, while this is not the end of the video that I wanted to have the melty brain up and running again at the end of this video. this has been very informative. The 1806s are going to be a great weapon motor solution, and them being so small means I'm going to be able to tuck them in and hide them away and keep them more protected in the future. The D-Shot is going to be so much better at getting the thing melting. As long as I can get all the gremlins out of the code, everything will work well. And I think with the new motor mounting solution, and also making sure that the weapons don't hit any of the internal componentry, I'm probably going to change the shape just slightly, keep the wheels exactly as they are, and maybe make the robot just that little bit longer, give myself a little bit more room inside here, just tweak and change a few things. So again, while it's not where I wanted to end up, I'm quite happy with where we are, because now I have a very, very clear picture of what is ahead for the dual spinner melty, and it should be up and running before that October meet. So if you want to see it actually fighting, subscribe, stick around, and you will see it get rebuilt and hopefully fight. Anyway, that is it for me in this video. I hope you have enjoyed that one, and I will see you in the next video.